Welcome to Lecture 22, 3.6, Polynomial and Rational Inequalities. So for the objective, we're solving polynomial inequalities. For solving polynomial inequalities, we're going to set the equation equal to 0. Then we're going to factor and set each factor to 0 to solve for what are called the critical values. Then we're going to set up a test box, or a test interval box. And pick test values to determine which intervals are true, or part of the solution. Then we're going to graph and write our answer in interval notation. Okay, so one thing to really notice here is once you start to see the inequality symbols going on and we're solving, we're going to end up having to do intervals for our answers. So if you have just a regular equation like x equals something, you're solving for basically one number. But when we have intervals, we're solving for multiple numbers. Let's go ahead and follow the steps for solving. So first, we're going to set the equation equal to 0. So let's go ahead, subtract the 21 and the x, so minus 21 plus x, minus 21 plus x from both sides. Then 2x times x minus 1 minus 21 plus x is less than 0. Let's go ahead and multiply out that 2x. And so 2x squared minus 2x minus 21 plus x is less than 0. Let's add the like terms right there and there. So 2x squared minus x minus 21 is less than 0. Let's see, can I factor this? Looks like this will factor into 2x plus 7, and then x minus... No, it's going to be 2x minus 7, and then x plus 3. So 2x minus 7 and x plus 3 less than 0. Now, we'll go ahead and find our critical values. So to do that, so critical values, we'll set each of these to 0 to solve. So 2x minus 7 equal to 0, and x plus 3 equal to 0. Solving, we get x equals 7 over 2, and x equals negative 3 are our critical values. All right, so for these equations, once again, as usual, if you want to know what you'll be graded for in exams, just take a look at what I show. So I've showed the factoring, and then I show the critical values. So please note, I write critical values when I'm solving for the critical values. What do we do with these? Well, we're going to set up an interval. So I have my number line here. That's a little long. Let's go ahead and do that into one number line. And then I'll plop in my intervals. So I have negative 3 and 7 over 2. So 7 over 2 is roughly 3.5. This splits my answer line into 1, 2, 3 separate intervals. And we're going to test to see which of these intervals is part of my solution. So let's see, setting this up for my testing. How do we test? We're going to take each of the factors that we had previously and set them up next to our testing interval. So we had 2 factors. Let me go ahead and set those up. So we have 2x minus 7 and x plus 3 are our testing values. And then we're going to go ahead and list, our test points. So what are our test points? What is the purpose of those? Well, the test points are a point that we pick from each interval, not including these guys, that we're going to use to plug in here and see what the sign is. All right, so I'm going to go ahead, I'll pick negative 10, 0, and 10. I tend to like to stick with those if possible. The next thing we're trying to figure out, let's take a look right here. What does our inequality say? We want this to be less than 0, which means it should be a negative number, not a positive. Okay, so that's what we're looking for. We want it to be less than, so we want it to be less than 0. And then we have sign. So for our interval, for the test box, we list our test point, all of the factors, no matter how many there are. So if there were 3 factors, I would have to add in another column, another row. Then we check the sign, and finally we check to see if it's less than 0. In our case, we're looking at less than 0. It is possible for an equation to have greater than. So now let's test. When I plug in negative 10 to my equation, I'll get 2 times negative 10 minus 7. So 2 times negative 10 is going to be negative 20 minus 7. So that's a negative value. So I'll just go ahead and put a negative for that. Don't have to write everything out. Just put the signs. So that'll be negative, and the next one will be negative 10 minus 3, which will also be a negative. Now, remember, our factors are multiplying together. So we have a negative times a negative, which means we would end up with a positive. Is a positive less than 0? The answer is no, it is not. The answer is going to be no. Which means that this interval is not going to be part of our solution. Let's take a look at 0. If I plug in 0, I get 2 times 0 minus 7, which is going to be a negative, and then 0 plus 3 is a positive. So I have a negative and a positive. Multiplying those together, I will end up with a negative. Is that less than 0? The answer is yes. So we'll go ahead and we're going to take this interval here as part of our solution. Now let's take a look at the last testing column. See if you can fill out this column by yourself. Okay, so putting in 10, we're going to get a positive and a positive. Positive and positive is a positive. Is that less than 0? The answer is no. Which means that this is not part of our solution. So we just take the middle interval, and then the question is, do we include the negative 3 and the 3.5? Well, since we don't have an equal sign under the inequality, we do not. So that is our solution. So the answer is negative 3, 3.5. So one thing to note, I am looking to see that you use the table for your checking your answers. So please make sure that you use a table when you're checking your answers. And that is something I will be grading for. Now let's take a look at B. So the first thing we do as usual, we're going to set this equal to 0. Well, what do you know? It already is set to 0, and it's already factored. So all we're going to do is find the critical values. What do you know? So critical values, we have x equal to 0, that's one factor. X minus 3 equal to 0 is the other factor. And then x plus 2 equal to 0. So if x equals 0, x equals 3, and x equals negative 2 as our critical values. Once again, I am looking that you list them as critical values. Now let's set up our testing. Okay, so testing, actually let me set it up a little higher. Okay, so setting it up right there. Putting in our values. So we have negative 2, 0, and 3. Ooh, now we have 4 different intervals that we're going to be testing. So it's slightly more that we're looking at. Okay, so let's go ahead and setting up our box here for our testing. A little more space this time. So the first line, I use my test points, and then I'm going to go ahead and list my factors. So I have these factors up there are what I'm looking at. So the x minus 3, and x plus 2 are the factors that I'm looking at. And then, what does my equation say about these factors? We want them to be greater than or equal to 0. That's what my equation is saying. Okay, and then I'll go ahead and leave this as sign for the bottom. Okay, so that breaks it up into 4 different intervals. Let's go ahead and pick some test points. I'll do negative 10. How about negative 1, 1, and 10? Remember, you have to pick a test point from in between these sections. You can't actually pick your critical value. And then, for my intervals, though, am I allowed to choose these critical values as part of my answer? Well, yes, because my inequality isn't equal to, we can go ahead and bubble those in. Those can be part of our answer. Okay, so I'll do the first column, and then I want you guys to try and do the other columns by yourself. So let's check the signs. Negative 10, okay, that's going to be negative. x minus 3, that'll be negative again. Negative 10 minus, or negative 10 plus 2 will be also a negative. Multiplying these together, we will get negative times negative, positive, times negative, negative. So is this greater than or equal to 0? The answer is no, which means this is not going to be used. Okay, let's take a look at the next intervals. Try them by yourself and see if you can end up finding out if we're going to use that answer for the interval. Well, using these test points, I get a negative, negative, positive. That's all going to be a positive. Is this greater than 0? The answer is yes. So we can use that in our interval. Yes. Then let's see, doing the next one. So we have positive, negative, positive. That's going to end up being a negative when I multiply them together. So that will not be part of my interval. No. And lastly, with the 10, that's positive, positive, positive. Multiplying those all together, we'll also get a positive. So the answer is yes, it's part of our interval. All right, we can go ahead and write our answer in interval notation, which is going to be negative 2 to 0. Oops, that should be an including negative 2. Union 3 to infinity, and that is my solution. Once again, main things I am looking for. You state your critical values, you show the testing, you show the graph, you show interval notation. Now let's take a look at rational inequalities. So this means ratio, remember, ratio is talking about fractions. But first, let's take a look at a question. If we tried to get rid of the fractions in this equation by multiplying both sides by x plus 4, like we do with regular equations, do we flip the inequality sign or not? What do I mean? Well, usually, if I wanted to get rid of the fractions in this equation, I would multiply both sides by x plus 4, right? And by x plus 4. And that would cancel out the x plus 4s in the fraction. But the problem with this, if I have an inequality, what is one thing that we remember about inequalities? If I multiply by a negative, what happens to the sign? The sign has to flip. Well, that's not too bad, right? But if I wanted to multiply both sides of this equation by x plus 4, do I flip the sign or not? Well, the question is x plus 4 positive or negative? And the thing is, we don't actually know if x plus 4 is positive or negative. Because we don't actually know, we cannot multiply both sides of the equation by this. Because we don't know if it's positive or negative. Because if it was a negative, we'd have to flip the sign. And if it was a positive, we'd keep the sign. But we don't know which one it is. So we have to create another way to get around this. In fact, we actually have to work with the fractions when we're working with inequalities. I know, it's, not a lot of fun. But that's what we're going to have to do. Okay, so we need to work with these. So we need to work with the fractions. Do we flip the inequality sign or not? The answer is we do not know if x plus 4 is positive or negative. So we cannot do this. Oops. So we cannot do this. All right, so let's take a look at example 2. Solve the following rational inequality. Be sure to answer in interval notation. So since we can't just multiply across by the fractions, we're going to have to choose a different method. We're still going to follow the steps we had above, which is going to set this equal to 0. So to do that, let's subtract the 3 over the 3 minus x from both sides. And then we have to do the building up property, because we're not allowed to multiply across by a binomial. Remember, because we don't know if we should flip the sign or not. So what's the LCD? Well, it's just the opposites. So let's go ahead and do the building up property. Feels like we're going back to the Stone Age. I miss being able to just get rid of the fractions. Okay, so 5, 2 minus x, minus 3 times 2 minus x, all over the 2 minus x times the 3 minus x, less than or equal to 0. Okay, so simplifying out the numerator, we have 15 minus, 5x minus 6 plus 3x all over 2 minus x times 3 minus x less than or equal to 0. Okay, simplifying, we'll end up with 9 minus 2x all over 2 minus x times 3 minus x less than or equal to 0. Okay, so we have it factored. That was the first step. Now we'll do the critical values. So we'll set both the numerator and the denominator equal to 0. So 9 minus 2x, equal to 0. 2 minus x equal to 0. And lastly, the 3 minus x equal to 0. And we get x equals 3, x equals 2, and x equals 9 over 2. Now, one thing to note. Even though this is saying less than or equal to, when I set up my testing interval areas here, we're not going to let all of them equal our test points. And you might be saying, why? Well, let me get to that real quick. Let me write down our test points first. So we have 2, 3, and 9 over 2 is about 4.5. So 2, 3, and 4.5. I'll go ahead and write that as 4.5 actually. Okay, so we'll go ahead drawing the intervals for my testing. I'll bring out my factors. So 9 minus 2x is one factor, then 2 minus x is the other factor, and then 3 minus x is the last factor. We'll want to know the sign, and lastly, what do we want to know? We want to know if it's less than or equal to 0. That is the last thing that we would check. So let's do the columns. Once again, please use this box or something very similar to it if you learned a slightly different method. But I need you to be showing your test points and your testing work in order to earn full credit on this kind of a problem. So the best way to do it is to just copy down this style of box. But once again, if you do have another way of testing and you're showing each of the testings, you can always just shoot me an email and ask if it's appropriate for the exam. And I'll let you know if I would think it would get full credit. Okay, let's pick some test points. Ooh, before that. For each of my critical values, are they going to be included or not? Because remember, this is less than or equal to. So they should all be filled in, right? Because we can let them equal to 0. Well, the answer is going to be, no, that's wrong. Why? Well, 3 and 2 came from the denominator. Can we let our denominator ever equal 0? The answer is no, we can't. So the 2 and 3 cannot be filled in, but the 4 can. Because it's from the numerator, it's okay to have that equal to 0. Once again, 2 and 3 cannot because they came from the denominator. Shucks. Let's go ahead with the testing. So let's pick a test point. I'll do 0 is easy. How about, 2.5. Not the easiest, but we'll survive. And then let's go with 4 and 10. Let's check those. So that's going to be 9 minus 2 times 0. That will give us a positive. Once again, a positive and a positive. The sign is a positive. Is this less than 0? The answer is no. So that will not be part of our solution. Now let's go on to the next one. 2.5, that's a positive, a negative, and then a positive. Multiplying those all together, we'll get a negative. Is that less than 0? The answer is yes. So we'll take this interval here. That is true. Now let's take a look at the 4. That's going to be positive, negative, negative. Multiplying those 3 together, we'll get a positive. Is that less than 0? The answer is no. So that between 3 and 4.5 will not be part of our solution. Lastly, let's take a look at our test point 10. So that's going to be, a negative, negative, and negative. Multiplying it all together, we end up with a negative, which is less than 0. Yes, so that is part of our solution. All right, last thing to do is to write our answer in interval notation. So you go from 2 to 3, union 4.5, comma, to positive infinity. And there we go. That is the answer. So once again, I look that you set it to 0, you have factored it, You've shown me that you found the critical values, listed it as a critical value. Then you give me the table with the test points, and you graph, and finally write an interval notation. That is what I will be looking for these kinds of problems. And we did not cover Objective 3 in Math 103. That is it for this section. Please email me if you have any questions.